Hey, this is section 3.7, formulas and functions. So what we're going to do today is we're going to rewrite equations. We're going to solve for different variables. So for the first one, we're going to start out with A is equal to L times W, and they want us to write this in terms of L, or really what they're saying is just solve for L. So I'm going to circle what I want to get by itself, because with all these variables it's going to be easy for me to forget. Well, L is attached to W, so I need to move W away. I'm going to divide both sides by W. So when I finish, I have L is equal to A divided by W. Okay, now they want us to use our new formula, and they want us to find the length of a rectangle that has an area of 35 square feet and a width of 7. So now I have this rectangle. The area is 35 square feet. The width is 7. I need to find out what the length is. I'm just going to plug it into my new equation because I know that the length is equal to the area divided by the width. So the length is equal to 35 divided by 7. So the length of my other side is equal to 5. So this side is 5 feet. Now let's look at another formula, the temperature formula. C is equal to 5/9 times F minus 32, and they want us to solve for F. So I look at this and I see this F is embedded in the parentheses, and then outside of the parentheses I'm multiplying by 5/9. Well, the first thing I want to do is I want to see if I can get rid of that fraction. So why don't we, I can multiply by the reciprocal. So the reciprocal of 5/9 is 9/5. Multiply both sides by 9/5. What I do to one side I have to do to the other. So now I have 9/5 C is equal to F minus 32. My equation already looks better. Still want to get F by itself. 32 is kind of hanging on, so I'm going to add 32 to both sides. Now remember, I'm adding because I have a negative or a minus 32. That adds up to 0. So now I have 9/5 C plus 32 is equal to F, or you could also write it F equals 9/5 C plus 32. Either one of these guys are correct. Okay, now we're going to rewrite equations in function form. So we really need to know what that is. A two-variable equation is in function form if one of its variables is isolated on one side of the equation. So y equals 3x plus 2 is an example of what function form would look like because y is isolated. Now some things that you need to know and remember is that the isolated variable is the output. It's also known as the dependent variable. And it is a function of the input. Now in this one, this variable is the independent variable, and it's also known as the input. Input, independent, output, dependent. So now we're going to ask us to do something else. They're going to want us to rewrite the equation. Okay, they want us to rewrite the equation so that y is a function of x. This is the fancy math way of saying, hey, I really want you to solve for y. Isolate y, get y all by itself. So once again, I've got all these two variables. I'm going to circle what I want to get by itself because that way I'm not going to forget. I'm going to subtract 3x from both sides. So now I have y is equal to negative 3x plus 4. An equally valid answer would be y is equal to 4 minus 3x. These are two different ways to write the exact same thing. Okay, now our directions say to rewrite the equation so that x is a function of y. So remember, this is just the fancy math way of saying, hey, I want you to solve for x. So now my goal is to get x by itself. Well, I'm going to subtract y from both sides. So now I have 3x is equal to 4 minus y. Going to divide both sides by 3. So my final answer is x is equal to 4 minus y all over 3. Now the next part of the equation, they want us to find x when y is equal to negative 2, negative 1, 0, and 1. They're giving me my input. So if I'm not sure when I'm taking a test or quiz or doing homework which variable I need to solve for, if they're giving me y and the other variable is x, I know I need to solve for x because x will be my output, what I get. So my input of y is negative 2. Here's my equation. X is equal to 4 minus negative 2 divided by 3. So that turns into 4 plus 2 divided by 3, and I get 6 over 3, or 2. My next one, I have negative 1. X is equal to 4 minus negative 1 over 3. So that's really 4 plus 1 because 2 wrongs don't make a right, but 2 negatives make a positive. 4 plus 1 gives me 5. Now I have 5 over 3. Next, I have 0. X is equal to 4 minus 0 divided by 3. Oh, that just gives me 4 over 3. Now 1, I have x is equal to 4 minus 1 divided by 3. 4 minus 1 is 3, so I get, 3 over 3, or 1. So notice the pattern in my output. 6 over 3, 5 over 3, 4 over 3, 3 over 3. Whenever I'm solving or finding the output for these linear equations, there will always be a pattern.